Hi, I've decided to tape the lesson for day 4. First, we have a 60 kilogram man starting from rest at the top of a 50-meter icy driveway that's inclined at 25 degrees with respect to the horizontal. So the first thing I'm going to do is draw a picture, and this is 15 meters. And since we're in the energy chapter, I know I want to find the initial height because we need to find potential energy. So the initial height from the diagram would be 15.0 meters times the sine of 25 degrees. And that gives us an initial height of 6.34 meters. Okay. Now, what I have here is I have a frictional force of 110 newtons. So if I'm using conservation of energy, I have initial potential energy plus initial kinetic energy. I have no spring energy here. Then I'm doing work with friction, and that will equal my final potential energy plus my final kinetic energy. I'm going to set my reference level, h equals 0, to be the bottom of the hill, which means I have no final potential energy. And it tells us what the frictional force is. The frictional force is upward. The displacement is downward. So I have to take that into account when I do the problem. Now my potential energy, I have a man that has a mass of 60 kilograms. I know my acceleration due to gravity is 9.81 meters per second squared. So I have a potential energy of m times g times h, and I found h earlier, plus 1/2 mv initial squared. Now I have frictional force times the cosine of the angle between the force and the displacement, and that's going to equal 1/2 mv final squared, and that's at the bottom of the hill. So I'm going to place some numbers in. This is 60 times 9.81 times 6.34. My initial velocity is 0, so that term goes to 0, plus my force of friction is 110. Now theta here is 180 degrees between the frictional force and the displacement. I know by the time I get to the bottom of the hill I've gone 15 meters, and that equals 1/2 my mass, which is 60, times my final velocity squared, which is what we're trying to find. So now I have to get out my calculator, and 60 times 9.81 times 6.34 gives me 3732. 100 times 15 times the cosine of 180 is negative 1,500, and that equals 30 times 30.0 times the velocity, final velocity squared. So now I have to subtract 3732 minus 1500, 2232 divided by 30 is going to be v squared, df squared. And when I do that arithmetic, I end up getting a final velocity at the bottom of the hill of 8.62 meters per second. I'm done with example 1. I think I'll make a separate video for example 2.